Are we ready? All right. Today we're going to be still talking about volume of prisms and pyramids like we have this week, except today we're going to be figuring out how tall they are. Maybe we know how much they can hold, their volume, but we don't know how tall the prisms are, like what you see in this first one. Okay, so we're going to learn how to figure that out today. If we read this first problem, it says that a movie theater has designed two bags that you see here, and they hold 96 cubic inches of popcorn each. Now that means, again, inches to the third power. If that number is inches to the third power, does that mean a dimension of my shape to me, or does that mean the volume? The volume, because our units, when we've done those answers, have always been cubed. So it's important for us to understand that that is the volume that they gave us, okay? Now it says here we want to figure out the height of each bag. In other words, these are both rectangular prisms, and we don't know how tall those rectangular prisms are. If you notice here, we have the H's missing. That's what we don't know, and we want to figure that out. So when we do most of this stuff, we always start with a formula. Does anybody remember the formula for volume of a prism? Karina?
Volume equals capital B and height.
Exactly. So for bag A, we're going to want to use volume equals capital B times H. Okay, that is our formula for volume of prisms, and that's what we're going to want to use to start to figure this out. Okay? Raise your hand if you can tell me what capital B stands for, because that's very important to us. Connor, what does that stand for? Area of the base shape. So when we figure out the capital B, we're looking at our prism, but we're really looking at the base and what shape that is. So on our first one here, bag A, what shape is our base? It's a rectangle because we see 4 by 3 different dimensions. So we know that it has a rectangular base, and we should know that because of the name of our prisms, right? Except technically, what is this prism? Square. Because this one has same units. So technically, we could call this one a square prism, but for any type of prism, we use the same formula. So we're good. What does the H stand for in our volume formula, Kai? So is it the height of my base's shape, or is it the height of my whole prism? I don't agree with you. I don't think it's the height of my base's shape. It's the height of the whole three-dimensional figure. So it's the height of the prism or pyramid when we get there. And that's a very important thing to know because we have to know which numbers go where. So that's okay. We just needed a reminder. So now let's see what we have that we can plug in. Were we given the volume? Do we know the volume of this popcorn bag? Yes, we know it should hold 96 cubic inches of popcorn. So we know what our V is. For V, I'm going to plug in 96. Do we have what we need to calculate the area of this base shape? Yes, because we said it's a rectangle, and to do area of a rectangle, we do base times height. So do we have those numbers? Yes, we could say the base measure of our rectangle base is 4. Then we could say that this 3 is the height measure of our rectangle base. So we're going to plug in our 4 and our 3. And that's what we are going to use for capital B, the area of our base. Do we know the height of this popcorn bag or prism? No. So we're going to leave that as H, our unknown. That's what we are solving for, what we are trying to figure out. So now we start by simplifying our expression here. This 96 stays there. What's 4 times 3? 12. So now we have 96 equals 12H. We have a one-step equation here, guys. What's happening with this 12 and H? They're being multiplied. If I want to know what H is, how do I undo the multiplication? We use the opposite operation and we divide. So 12 divided by 12 is 1, and 1 times H is just H. That's why it gives us just our variable. Now, if I divided by 12 on this side, what do I need to do on the other side? Divide by 12. We have to do the same thing. That's a math fact. What's 96 divided by 12? 8. So the height of our first popcorn bag is 8 inches tall. All right? Do we have questions on that one? How we got those numbers, what we put where? We're okay with that. Okay, let's try bag B now. So we need to figure out how tall bag B is. Now it's also a prism, so we're still going to use our volume equals area of our base times the height of our prism. What is the volume of this popcorn bag? 96. It said 96 each. So both of these can hold 96 cubic inches of popcorn. So we know that part of our formula. Do we have the info to figure out the area of our base shape? Yes. Now it's a square, so you could consider that the area formula base times height or side squared because it's 4 times itself. We're doing 4 times 4 here. Those are the dimensions of our base shape. So that's what we use to find the area. Do we know the height of this prism? No. So we're going to leave that as our unknown. So now we have 96 equals what? What's 4 times 4? 16H. So once we get ourselves here, we're at our one-step equation part here. These are being what again? Multiplied. When they're smushed together, it indicates multiplication. So we do what to undo that? We divide both sides by that number. So we have H will equal 96 divided by 16. Who's worked ahead of me? Who knows that? What's that? 6 inches. Okay, so that is 6 inches in height for this one. Questions about how we did part of this? Sorry, guys, we don't have a microphone for you, so hopefully you don't have any questions. Anybody? No. Okay, let's look at the next part. We're still going to be talking about our popcorn bags, but we're going to do something different with them. So we're going to look at the next section, okay, and see what this is talking about. Now, says here, which bag should the theater choose to reduce the amount of paper that they need? If we want to reduce the amount of paper, do we want one of them to have less or more than the other? Less. Because we want the least amount in order to reduce our waste. So we're going to help them figure out which bag they should use since they both hold the same amount of popcorn, right? Which one uses the least amount of paper, though, so we have less waste? What does that mean? Is that like finding our volume? How? It's like finding the what? Oh, circumference, that's a circle. Hold on, let's think about this, guys. If I want to know how much paper I used to build that bag, how can I calculate that? It's not circumference, it has nothing to do with a circle, Jacob. Surface area. Because if I know how much paper it used to make the front and the back, the area of those, and the sides, if I add it all together, wouldn't I then know how much paper was made or used to make the whole thing? So that's what we're doing. This is asking us to practice our surface area. Now, next week, our test is going to have surface area and volume on it. So we want to go ahead and practice this and see if we remember what we need to do. We're going to start with bag A. So we want to start calculating the surface area of our bag so we can figure out how much paper we use for each one. Now you're going to have to look at your dimensions since you can't see mine. Okay, so you're going to have to look at your paper. But for bag A, let's start with maybe the front. Okay, we're going to figure out the area of the front side. And that'll tell us one piece. But is our front the same as the back? Yes. So really when we do this, we're doing the front and the back part of the bag. What shape are those front and backs? They're rectangles. To do area of a rectangle, we do area equals base times height. Now looking at your bag A, raise your hand if you can tell me the base measure and the height measure of that front rectangle. What would the measurements be that I need to use for my front rectangle there? Daniel?
460.
4 and on bag A, I don't see a 6.
Oh, sorry.
4 and
8.
4 and 8. Because 4 is the base measure of the front rectangle and 8 is the height measure of the front rectangle. So what is the area of my front rectangle then? 32, because 4 times 8 is 32. Now that's just the front though. And you told me the front and the back were the same. So how many of these numbers do we need? 2. So we need that twice. What's 32 twice? 64. So the front and the back of our first bag, we already used 64 square inches of paper. So we've done our front and our back. What about the sides? That would be a good thing to do next. How about what amount of paper do we need for the sides? Is the left side going to be the same as the right side of my rectangle, on my rectangular prism? Yes. So we have 2 of those. Looking at your bag A, raise your hand if you can tell me what dimensions we would use to calculate the area of the sides. Jada?
3 and 8.
3 and 8, because 3 is the bottom part of that side rectangle, and 8 is how tall that side rectangle is. So 3 times 8 gives us the 24 square inches for the side, just one of them. You said we needed 2 though. So if we need that 2 times, that's 48 square inches. So far we've done our front, our back, and our sides. What have we left off? What do we still need to do? The base. Do we have a top? That's something to think about. Do these popcorn bags have a top?
No.
No. So we only need a bottom now. So whatever we figure out for the bottom area, we're only going to use that once because there's no lid on it. Now the bottom is also a rectangle. And we talked about the bottom, our base of the prism up there. We had done the 3 times the 4. And what do we get for that area then? 12 inches squared. So now that I know the front amount and my back, I know the sides, I know the bottom. How do we figure out the total amount of paper? We add it all up. So we need to take our 64, our 48, and our 12 and add that all up. We do get 124 square inches of paper to make that bag. Okay? We're going to figure out the amount of paper for bag B now so we can tell the movie theater which one they should use so that we have the least amount of paper. Does bag B have a front and a back that are the same? Yes. So we're going to use that same format, our same plan of figuring out the surface area from over there here. Now, our front and back of bag B are also rectangles. So we do area equals base times height. Jorge, what are the dimensions that I need to use for my front rectangle on bag B? What do I need to use to figure out the area of that?
Area equals base times height.
Okay, but what numbers am I plugging in? What is the base number that I can use on my front rectangle? What's the height number?
4 and 6.
4 and 6. So 4 is how long that front rectangle is, or the base measure. The 6 is how tall that front rectangle is. So what's our area of our front rectangle for bag B? 24. But our front is the same as our back. So how many of those 24s do we need? 2. So when we have that twice, that gives us 48 square inches. I think you guys might have a hard time seeing that. I wrote 48 square inches at the end. Do we have two sides on this bag also?
Yes.
Yes. So we have our sides, and we need that 2 times. Now, guys, I was hoping that somebody would have said something and noticed, but aren't our sides the same as that front rectangle? If you look at the numbers, that base length on that side rectangle is 4, and the height would be 6. So really, what could we have done to our first 24 area? We could have multiplied it by 4 instead of the 2, but that's okay. We know that this is 24, and we need that twice again, so we get 48 again there. Okay, we could have just done that times 4, but that's okay. What do we still need to figure out for bag B? Our bottom of that bag. How much paper did it take to make the bottom? Now that one's technically a square. You can think of area of a square as base times height or side squared. That was our 4 times 4, which gives us 16. So now we do what with all of these? Add them. So let's see when we add this, what we're going to get so we can compare them. Don't yell it out. Give everybody a chance. $112 square inches. So now that we know how many square inches of paper it took to make both bags, which one would we want the movie theater to use so that they have less trash? Bag B. That's the one that we want them to use. Okay? Questions on that, our little surface area review. Now guys, could we technically call that lateral or total? No, because lateral doesn't include our bases at all. And in both of these, we included one of those bases, right? And total, we would have needed a top. So this was not technically lateral or total, but we did figure out some form of our surface area. Okay, so that was a good review of that. Let's look at number 2. Let's look at number 2 here. All right, so we have a triangular prism this time. And it tells us that the volume of that is 78 cubic centimeters. Okay, and we want to know how tall this prism is. Okay, now like we did when we were figuring out how tall our popcorn bags were, we used the formula volume equals capital B times H. That works for all of our prisms, no matter what shape their bases are. Okay? Now, what we're doing for capital B will be different though, right? Because don't we have a different shape that we're finding the area of? That will be slightly different. Let's plug in what we know. Do we know the volume of this prism?
Yes.
They told us that the volume was 78. Now, capital B stands for area of the base. What shape is our base?
Triangle.
It's a triangle. Remember, we know that based on the name. And then we also look at the fact that prisms have 2 bases. And the 2 things that are the same on here are the triangles. So this that I just outlined is our base. To find area of a triangle, we have to use half of its base measure times the triangle's height measure. Do we have what we need to figure out the capital B?
Yes.
Yes, so we're gonna put that stuff in here. We have half. What is the base measure of my base shape? Does it matter which of these I use?
No.
No, because this was a right triangle. You can see that up here, guys. And as long as they connect at a 90-degree angle, we can say that this one is the base measure, and we can say that this one is the height measure. So we're gonna plug in 4 for the base measure of my triangle, and the height measure of my base triangle here is 3. Now this last H here stands for height of our prism. Do we know how tall our prism is? No. So we're gonna leave that here as our unknown. Now you have two options here. You can multiply 4 times 3, then take the half of it, or some of you, if you're really thinking about this, you can just take half of 4 and get rid of that half immediately. You'll end up with the same result. So let's try it by just multiplying. So I have 7d8 still is equal to half of 4 times 3 is 12. Then we have times h still. So at this point, what we would do is take half of our 12. What's half of our 12? 6. So we have 78 equals 6h. Now here we are at our one-step equation again. How do I undo the multiplication of 6 and h? We divide, we use the inverse operation, and so we're going to put 78 inside the house, 6 outside. Don't yell it out. Let's let everybody figure it out here. Did we get 13? And this would be 13 centimeters. It is a dimension of our shape, so it is not squared or cubed. It's just the centimeters. How do we feel about working backwards with our prisms? Questions about what we did here? Yes, this stuff will be on our STAR test. We will review it again, of course, before STAR, but yes, it will be. Let's look at the back. We've talked about prisms. We need to talk about the other one, our pyramids. So, let's see here. We have a pyramid, and they gave us the volume of this pyramid. They told us this pyramid can hold 494 cubic meters. I've already told you it's a pyramid, but specifically, raise your hand if you can tell me what type of pyramid this is specifically. What shape is its base? A rectangle, so it's a rectangular pyramid. Pyramid because it only has one base and all of my sides meet at a single vertex or point. That's why it's a pyramid. It's a rectangular one because the base is in the shape of a rectangle. Hurry, because they're probably going to hear it. Find something else to use. Now, does anybody remember our formula for volume of a pyramid? Because it's slightly different than our prism. There's only one difference, but there is something different in it. Lizette? Perfect. So it's 1/3 my area of my base times my height. So it's essentially the same as our prisms, except we know it's only 1/3 of the amount that a prism can hold. So we divide by 3. Okay, now we need to think about what we know here. Do we know the volume of this pyramid?
Yes.
Yes, they gave us that. So the volume is the 494 that they gave us. Of course, our 1/3 is going to stay there for now. Capital B stands for area of my base shape. We have a rectangle. So that means I have to do base measure of that rectangle times height of my rectangle. Do we have that information? Yes, we could say maybe this one is the base measure of my base shape, and this is the height measure of my base shape. So let's plug in those things. We said the base measure of the base was 12. The height measure of the base is 13. Now I'm going to show you the other way that I was mentioning you could start simplifying this. What could I put underneath 12 to make it look like a fraction like this one? A 1. So if I put a 1 underneath it, and I'm looking at just my 1/3 and 12/1, can I cross simplify anything there? The 12 and the 3. So 3 divided by 3 is, so now that makes that a 1. And we know that 1 divided by 1 is just 1. That's essentially gone now. 12 divided by 3 is 4. So that goes there now. So now, all I have is 494 equals what 4 times 13 is. So let's figure that out real quick. That gives us 52. Now, what we still need that we do not know is the height of our pyramid. So that is what we still have to figure out. So guys, you can use this and divide one of those numbers by 3 first, or you can do what we did on the front. Just multiply these first, then divide by 3. That's going to be up to you which way you want to do that. But now that we're here, what do we do to get h by itself again? We divide, because these are being multiplied. So I'm going to divide both sides by 52. So that means we need to have 494 inside the house and 52 outside. Now, some of us still take a little too long with our long division. We need to get used to estimating. This is very close to 50. 50, 100, 150, 200, 250, 300, 350, 400, 450, that's 9, 500. I'm going to guess and check 9. That's what you all need to do. Estimate these values, guess and check something. So let's see. Nice. Let everybody figure it out. 9 times 2 is 18. 9 times 5 is 45, plus 1 more is 46. So that's 468. That's going to work out really well for me. Now I do my subtraction step. Make that an 8, make that a 14. That's 6 left over there and 2 left over here. How do I keep dividing now if I have nothing else to bring down? Connor, what do I have to do? Okay, so my decimal first. I add my decimal, so then I can add a 0 and bring that down. Now again, let's estimate. We said this was close to 50. 50, 100, 150, 200, 250. I'm going to guess and check 5 this time. So 5 times 2 is 10. 5 times 5 is 25, with 1 more is 26. So that 52 times 5 is exactly 260. So that means that 494 divided by 52 is 9.5. That is the what of my pyramid? The height of my pyramid, 9.5 meters.
Yeah.
How do we feel about that one? Do we have questions on this? Do we have questions on this one? Okay, we're going to do our last one really quickly. We're starting to forget, I think, about our microphone.
Oh, yeah.
But yet, there you're still talking. So now again, we are given the volume here, and we want to know what is the height of this shape. Raise your hand if you can tell me the name of this one. Specific name, Jayla.
Pyramid.
It's a triangular pyramid. Very good. She knows it's a pyramid because there's only one base on it, and that base is in the shape of a triangle. That's exactly why she named it a triangular pyramid. Now, even though it's a triangular pyramid, our volume for pyramid formula is still the same. We still do that 1/3 of the area of our base times our height. So let's start plugging in what we know. We know the volume is 51.2, and that's going to be equal to 1/3 of the area of our base. Now let's think about this. Because our base is what shape again?
Triangle.
A triangle. To find area of a triangle, we have to do half of the base times the height. Do we have everything we need here to figure out the area of our triangle?
Yeah.
Yes, because they're showing us here that one dimension of our triangle is this 4, and the other dimension of our triangle is this 12. So I have to do half of my base measure of my triangle, which we could say is that 4. I'm gonna have to be careful in my parentheses here. It's gonna get a little confusing. And then times the height measure of that triangle. Okay? Now, this H again is for the height of my pyramid that I don't know yet. Guys, I'm only using these parentheses to indicate multiplication still and to separate my values, okay? So watch how we're gonna simplify this. We still have our 51.2 that's still equal to the 1/3 here. Let's do something inside of these parentheses. I'm gonna leave that half there still, but I can do my 4 times 12. What is that?
48.
48. Now, we did something inside our parentheses, but we still need to finish simplifying that. So I have 51.2 is equal to 1/3 of half of 48. What's half of 48? 24. And then that's still times the height of my pyramid that I don't know yet. So now, let's do what we did before. Put a 1 underneath this 24 and think about what's 1/3 of 24. In other words, 24 divided by 3 is 8. So we have an 8 here, and 3 divided by 3 is 1. So now what we have is 51.2 is equal to 8 with my H. Because that 1, don't need it. I have 8 and H left. So what do we do now to figure out H? We need to divide. Since they're being multiplied together here, we need to divide. So we have 51.2 divided by 8. I have no ball to kick to the wall, so I'm gonna throw my decimal up top. 8 fits into 51 6 times. 6 times 8 is 48. We got 3 left. 8 fits into 32 4 times. No remainder. So we get our height is 6.4 kilometers. Both classes, these are hole punched. Let's put them in our binder. These are notes. We have 1 minute to the bell. If you need missing assignment copies, let's get that going.
So much.